what we were trying to focus on was what types of coordinates, coordinate rules produce similar figures, non-similar figures, and for a pair of similar figures, how can you use a coordinate rule to predict the side lengths of an image? So, did anyone do any predicting? Like you looked at rule number 1. Anyone kind of guess what was going to happen there, Aiden? So it was just going to move. Okay, we'll use your word shift. What about number? Now, obviously, there had to be something to do with those coordinates, right? With the plus minus. All right. What about the other? What about hat number 2? It's going to shift again because it's kind of similar to hat number 1. And then hat number 3 had a little bit different, right? You were going to shift and it was going to also do what? It was going to get bigger, right? Right? Wasn't that the rule? Wasn't it 3y or something like that? Yeah. So it was going to shift and it was going to get bigger, right? What about the hat 4? Because both things were 0.5x, 0.5y. Yeah, it was going to get smaller. And then hat 2 or hat 5 should have got bigger, right? Because the numbers were bigger than 1, but they weren't the same number, right? They weren't the same number at all. All right. Anthony, can you go get that to Isabel? All right. So if you went and completed your table, it should look something like this. All right? Because again, if you take 1, 1, and here's your new rule. So basically, this is 1 plus 2 to give you 3, and 1 plus 3 to give you 4, right? You only got to do the x coordinate here, the y part here. Okay? Here we subtracted. So 1 minus 1 is 0, 1 plus 4 is 5. And then we started to multiply, right? You had an addition plus and a multiplication, and then these were 2 straight multiplying. So notice how the coordinates got smaller or bigger or moved, okay? So those predictions were pretty good. So this is kind of what your graphs should look like. Something like that. Okay? With Mug's hat being the original. So if you look at the first rule, right? What do you see from Mug's hat to this one? It shifted which way? Right? His hat is here, so it kind of went right a little bit, right? And then it went up, right? So when those positives, when you add to the x or you add to the y with the rule, it moves it right, and then it moves it up, right? Because if we add to the y-axis, that means we go up the number line, right? When we add to the x-axis, that means we go right along the number line. See that? What about for the second rule? Oh, where's hat number 2? There he is. No, he's down over here. So look at where hat number 2 is compared to Mug's hat. Where did that go? It went left 1, right? So it went to the left once, and then it went up a bunch. It went up 4, right? So every point got shifted left 1, up 4. Because again, that minus sign is going to go left. Okay? We're up here, the plus sign made you go right. For the y's, the plus sign will make you go up. So where would the minus sign make you do? What do you think the minus sign would make you do on the y's? If it was y minus, I don't know, 3. You would go down. Good. All right, so hat number 3. What do you see the difference with hat number 3 to Mug's hat? It's longer, so it got shifted to the right, right? 2 spaces. But then we blew the y's up by 3, which means we stretched it. So that's why it's skinnier, right? You see the base of Mug's hat is wider. We just basically took that hat, you basically grabbed it at the top like you're pulling it up. So it's skinnier, it's taller, I should say, right? What about hat number 4? Look at the rule for hat number 4. Yeah, because look at our scale factor. We're multiplying by less than 1, right? Which means it's shrunk. And on your paper there, that was probably pretty tough to draw, right? You had a pencil, it was really tiny. I mean, compare, look at hat 4 to Mug's hat. Much smaller. Now what about the last one, hat number 5? Yeah, we kind of blew it up, right? It was 2x, which means we doubled the x's, right? But then we tripled the y's, which means we also stretched it. Okay? So we blew it up with y's and then stretched it height-wise. So, because again, these numbers aren't the same. If this was 2 and 2, we would have basically doubled the figure. But they're not the same number, right? Which means if they're not the same number, these figures aren't similar, right? All right, so let's go back to our sheet. So that was part B, basically. So it says, without measuring, visually compare the angles and side lengths to those of the hats. Well, hats 1 and 2 are actually the same as Mug's hats in terms of the sides and the angles. So hats 1 and 2 are the same as Mug's. And again, that's talking about just angles and side lengths, nothing else. Okay? Now the width of hat 3 is the same as Mug's, but the height is 3 times as big. Remember, that's the one we stretched, right? And then in hat, the width and height of hat 4, we said was half, right? Is half as big as Mug's, right? That got smaller. Now remember, why aren't we talking about hat 5 here? Because nothing's the same. We doubled one side, we tripled another, so it's all screwed up. And then the angles of hats 1, 2, and 4 are the same as Mug's. So which hats are similar to Mug's? Hats 1 and 2 and 4. Because we shrunk both X and Y by the same amount. Right? All we did in rules 1 and 2, hats 1 and 2, was move it, right? The sides never changed. We just took the whole thing and just moved it. So it's the same exact hat. All right, so hats 1 and 2 are similar. And we have to explain, right? Because they have the same shape. Oops. I probably put that word over here. Corresponding angles are equal. And their sides and this is basically for hat 4, have been multiplied by the same scale factor, which was 0.5. right? Hat number 5 they didn't use the same scale factor. We used 2 and 3. And hat 3 we shifted it and then we stretched it. So that's where it kind of got screwed up. All right, so let's see if we can figure out how to make some rules. I know we're almost at the end here. Okay, and that worksheet I gave you is homework. So if the side lengths are 1/3 as long as mugs, what would our rule be? What would our rule be? Anthony. Yeah, so 1/3 X, 1/3 Y. That's what you would do, right? This would make the figure smaller, right? Because 1/3 is smaller than 1, right? Yes? Okay. What if the side lengths are 1.5 times as long as mug? What would that rule be? Aiden. Yep. And 1.5y. Right, we're multiplying. Now, what if the hat is the same size as mugs, but it's moved right 1 unit and up 5 units? What would that rule be? Aiden? So what are we doing to the x if we move it to the right? We're adding 1 to it. Good. And then what are we doing to the y if we move it up 5 units? We're adding 5 to that. So that would be the rule for that one. Okay? And then on the back, you can see we have your summaries on the back of the 3rd page. So again, get to know your summary. So that worksheet I gave you is homework. Okay? It's just 2 sides. All right?